that is Is equal to how much? That is equal to R plus SL. Equation 1. Second equation getting V naught S equal to how much? Is into 1 by SC. Equation 2. So now this for first equation I draw a block diagram. For second equation I draw a block diagram. So each equation is represent one block diagram. So first equation gives a one block diagram. Second equation gives another block diagram individually. Then if you do the block diagram, first equation block diagram, second equation block diagram, two small block diagram, if you combine, then you can find the final block diagram of this electrical circuit, RLC electrical circuit here. So you see here, that is written here. So you see, for equation 1 can be implemented, you see this equation 1 I am determined here. This equation 1 here. For what is the equation 1? So equation 1 was, you see, equation 1 is there. If you write here equation 1 was Is is equal to how much? V naught S VIS Is equation 1 is equal to VIS minus V naught S by R plus SL, equation 1. You see, that can be written as 1 by R plus SL into VIS minus V naught S. You see here. So this equation 1, this was equation 1, Is equation. So I am writing here, you see, 1 by R plus SL. This value represent a transfer function value, pure transfer function value. And this is the signal, a input signal VIS, this is another signal V0S. Two signals are subtracted. If the two signals are subtracted, you represent if this first input of VIS la input signal, so you start from the left hand side, bam patru prathame arambh karibo, this left hand side to bam patru input signal VIS. So output signal, kana these two signals subtraction hoichi, when two signals are subtracted, you use a summing point. First arambh karibo this subtraction signal. As this is the subtraction of two signals, VIS and V naught S, this signal subtraction kara hoichi. आम कौन करवा बर्तमान VIS V naught S को आम रिप्रेजेंट कर समिंग पॉइंट इनपुट है VIS एंड माइनस V0S और V naught S, सो माइनस अच्छी, सो अप्लाई V naught S विथ माइनस साइन, यू सी हियर माइनस साइन, VIS पॉजिटिव साइन, V naught S माइनस साइन. सो VIS minus V naught S is equal to the output signal. This is the, you are getting VIS and the V naught S from this summing point. Summing point is used for subtraction of two signal or addition of two signal. Here two signal subtraction achi VIS, V naught S. So VIS the first VIS ta prathame naba left hand side ro reference line kara input signal. Okay, so V naught S dela output signal ta dabo tale dabo bottom. So one is a positive signal VIS, minus is V naught S. So VIS minus V naught S is equal to, you are getting the output signal, this error mark. So output of the summing point is VIS minus V naught S. So what happens here? You see, this signal is multiply with a transfer function value. So I have told you mu tamu kahithili मन लख पिला माने, you see, if input is equal to XS, block diagram is GS. So what is the IS output? Now YS is equal to, always remember, input signal, what a block or input signal into the block transfer function value. Input signal into block transfer function. Signal को जितने कि तमें input दो, तो input signal multiply the transfer function value is equal to the output signal. So similarly in this case, here a signal अच्छी बर्तना VIS minus V naught S, मुझे ताको multiply कर जो transfer function value. That's why this transfer function value 1 by R plus SL. This 1 by R plus SL you can represent by a block value. You see here block value here. This is the block value. This is the block value here. So VIS and the V naught S put in a block value because this signal into 1 by R plus SL is equal to IS. So which is the given the equation 1. In the equation 1 you are getting in the equation 1. What is the equation 1? Equation 1 is VIS minus V naught S by R plus SL is equal to IS, output IS. That's why this signal VIS minus V naught S, when multiply with R plus SL, 1 by R plus SL, that become output is equal to IS here. IS, you are getting the output signal. Okay. So this is the block diagram for equation 1. For equation 1, this is the block diagram. For each equation, there is a block diagram. Okay. If there is 5 equations, you draw 5 block diagram, combine finally to get the final block diagram. So this is for equation 1, we are getting the block diagram. If you go to for equation 2, you see the equation 2. What was the equation 2? You see in the equation 2 was, so in the our problem in the equation 2 was IS is equal to how much? IS into 1 by SC was how much? V naught S. This was equation 2. Equation 2 एटा मतलब पेला माने VIS. Equation 2 was आउ थरे मु लिखि दूची रेड कलर V naught S is equal to IS into 1 by SC. Okay. So in this is equation 2. So this equation 2 was there. This equation 2 you represent it in block diagram. Each equation becomes a block diagram. You see here. So how many signal in this equation? One signal is I of S, second signal is V naught S. Two signals. You see. So I of S is the input signal. Because V naught S in this equation, what is the output? Left hand side is output. So left hand side is depends upon the right hand side signal in this equation. So you see input signal IS multiply with a transfer function value 1 by SC. That means this transfer function value 1 by SC, a transfer function value that represent a block, that can be represented by a block. This transfer function value can be represented by a block and inputting a signal IS. So you see here I am 1 by SC, I represent a block, and what the input signal? IS. Means input signal into 1 by SC, how much? IS into 1 by SC is equal to V naught S. Because I have told you always for each block, input signal into its block transfer value is equal to output signal. So that's why, so IS into 1 by SC is equal to V naught S. I mean, this equation is represented by this block diagram. This is the block diagram of equation 2. Okay. So now we are getting the first equation block diagram, one equation block diagram, this is the equation 2 block diagram. Then combine, you see the overall block diagram of a series RLC circuit, which is given the question, series RLC circuit. We are getting two equation, two block diagram. Now we combine these two block diagram, we combine two individual block diagram. If you combine, then you will get the final block diagram of the RLC series circuit. You see, combine here. So first equation you see. So you see the combination. So I just draw here. So what is the first equation? First is I draw just. So for the first diagram like that. First diagram. This is the first diagram. A summing point here in the first diagram. This is V, IS. This is V naught S. The first diagram like that. V, IS, V naught S. So what is the output? Output is V, IS. So VIS plus, V naught S is minus. So VIS minus V naught S. This was the with a block value. What is the block value in the first diagram? 1 by R plus SL, first one. So what is the output here? Output is equal to IS here. This is the block diagram, first diagram. So what is the second diagram? Second diagram पिलाने कौन था हम second diagram? Second diagram मतलब this part IS into put a block diagram 1 by SC, output V0S. So combine the second diagram. So this is IS here. So this is 1 by SC. So what is the output? Output is V0. You see, V0 is the first summing point wants V0 S, but V0 is 0S available in the last. So this is output V0S. This output V0S that is connected to the summing point V0S or V0S. Now this is the block diagram. This is the block diagram, final block diagram of this RLC series circuit. Okay. So means what is the final procedure to draw a block diagram from electrical circuit? The procedure to draw a block diagram from electrical circuit, what are the procedures? What are the points are discussed here? So number one, convert any electrical circuit in time domain form, convert into S domain form by using Laplace transformation. Then write down the equations of a current passing through the all of series branches or voltage in shunt branches. Means you see, after finding the S domain circuit Laplace turkeys, for series branch you find the current equation, and for parallel branch or the shunt branch you find the voltage equations. So by using this current equation, voltage equation which are in the Laplace transform form or S domain form, then for each equation draw the block diagram for all the above equations individually. Then if you are getting 5 equations, for each equation you draw one block diagram. Finally, you combine these block diagrams properly and you will get the overall block diagram of the problem given electrical circuit. Means in this here time domain circuit is given. So you convert into S domain circuit or Laplace domain circuit. Then from Laplace domain circuit you find the current equation for series branches and voltage equation for shunt branches or parallel branches. Then using this current equation and voltage equation you draw individual block diagrams for each equation. Finally, you combine these equations or block diagrams, you will get the final block diagram of this given question. Okay.